Okay, today we are going to be working on, again, we're on unit 11.2, and what we're doing is just more binomial expansion. Okay, so we're going to take it up just a little bit today and do some more binomial expansion. Okay, for example number 1, just like what we were doing last week, I would like you to expand, okay, expand x plus 5 cubed. Expand x plus 5 cubed. So we are going to do the exact same steps that we did last week on binomial expansion. Your first step is we need to figure out the number of terms. So remember that the number of terms is always one more than the total exponent number. So since your exponent number here is 3, that means we're going to have 4 terms. So put your 4 spaces. Okay, then the next step is we're going to put in our first term or first part. Okay, and your first term is doing what? Increasing or decreasing in exponent value?
Decreasing.
Decreasing, right. Okay, so your first term is decreasing. This is going to be your x, so x cubed, x squared, x to the first, and x to the 0. Then your next step is to put the second term. Okay, second term will be increasing in exponent value. Make sure that you're putting these in parentheses, okay? It's not 100%, or it's not absolutely essential for this example, but I want you to get in the practice of putting your terms in parentheses so you make sure that you remember to distribute that exponent to all of the parts, not just the letter, okay? So second term, increasing. Then we're going to put in our Pascal's triangle coefficient. So Pascal's triangle. So I don't have my Pascal's triangle on the top of my paper right now, but I can just make a real small one. Remember, it always starts with 1, then 1 and 1. 1, 2, 1. 1, 3, 3, 1. How do I know when I have enough layers? When the second number is there. So your total exponent is 3. That means I have to get to the layer or the term where this is going to have this as a number in there. So if we include these, we put 1, 3, 3, and 1. And then your last step is always to clean it up, okay? So when we're cleaning up, here this is really just x to the third. These go away, so it's times 1. So your first term is just x cubed. This is going to be 3 times x squared times 5. So 3 times 5 gives you a positive 15 x squared. Then we're going to be multiplying 3 times x times 5 squared is 25. Multiply that together, we get plus 75x. And then finally, 1 times 5 cubed is 125. So plus 125. That is your binomial expansion. Okay, that is your binomial expansion of that.
Yeah, I do.
3 times 25 is 75. Okay, be very careful because especially when they have numbers in there, a lot of people make mistakes and they don't realize that you have to be multiplying those numbers, okay? It's not, these coefficients are not always going to be the actual coefficients there, okay? It's just what the coefficient of that term is, but you have to multiply them together. Okay, try another one. Same thing for number 2. Again, I would like you to expand. This time I want you to expand x cubed minus 2y to the 4th power. X cubed minus 2y to the 4th power. Now we have our 5 steps, but technically, remember I put in that step 0 that I want it to make sure that you make it positive. Okay, so here, if I was going to make this positive, this would just be written as x cubed plus negative 2y to the 4th power. So you do have to make it positive. Then for step 1, we put in your number of terms. If it's to the 4th power, there's always one more term than there is powers. So there's going to be 5 terms, so 5 spaces. All right, your first term will be decreasing in exponent value. So first term is decreasing, so that's x cubed to the 4th power. Again, make sure that you're putting those in parentheses. So x cubed to the 3rd power, x cubed squared, x cubed to the 1st, and x cubed to the 0 power. Your second term is increasing in exponent value. So your second term here is actually the negative 2y. So negative 2y to the 0, negative 2y to the 1st, negative 2y squared, negative 2y cubed, and negative 2y to the 4th power. So you put in your second term increasing. We're going to use our Pascal's triangle. Do I have enough layers in my Pascal's triangle from what I had earlier?
No.
No, but I can go back. You can write a new one, or I can just go back to this one and you can write one more. Okay, I'm just going to write one more level. So 1, 4, 6, 4, and 1. If you don't have these memorized, that's fine. You can always draw the triangle. If you happen to have them memorized, that's totally fine. Okay, I don't have to see where you drew this triangle. So your Pascal's number is going to be 1, 4, 6, 4, and 1. And then our last step here is to clean up. So when we clean up, this is going to be 1 times x to the 3 to the 4th power. Are those multiplying or adding? Multiplying. So x to the 12th. In here, anything to the 0 power multiplies to be a 1. So really it's x to the 12th times 1. So we're just going to write x to the 12th. Here we're going to have 4 times x to the 9th times negative 2 to the 1st is a negative 2 times a y. So 4 times negative 2 gives you negative 8 x to the 9th y. Your next term you have 6 times x to the 6th. Negative 2 squared is a positive 4 times y squared. Make sure when you multiply these together that you're putting the sign in between. Okay, 6 and 4 gives you 24. We do have to put positive though. Okay, so plus 24 x to the 6th y squared. Then multiply 4 times, this is going to be x cubed, times negative 2 cubed is negative 8 times y cubed. So negative times positive gives you minus 32 x cubed y cubed. And then finally, this cancels to be a 1. Negative 2 to the 4th power is a positive 16. And y to the 4th, so plus 16 y to the 4th. Coincidentally, if you want to notice this, you don't have to, but anytime you have a negative in your original problem, your terms are always going to alternate. Okay, it's always going to be plus, minus, plus, minus, plus. Okay, that's just a means of checking your work, so to speak. Okay, anyone have questions on how I did that expansion? Okay, now we're going to make it a little bit more difficult. Okay, we're going to do one that's a little bit more difficult. It is not anything that you cannot do. Okay, it just looks different, and people like to complain just because they see a fraction. It does not change anything. So if I want you to expand, sorry, I forgot to write the expand. Expand x over 2 plus y over 3 cubed. Follow the exact same steps. Just because there's fractions does not change anything here. So, first you want your number of terms. How many terms, or I'm sorry, first make it positive. It already is. Then, number of terms. So how many terms will there be? 4 terms, okay? Cube means 4 terms. So 1, 2, 3, 4 terms. Then your first term is doing what? Increasing or decreasing in exponent value? Decreasing. So your first term is x over 2 to the cubed power. Okay? The denominator goes with it. It is nothing different. So x over 2 cubed, x over 2 squared, x over 2 to the first, and x over 2 to the 0 power. Then your second term is increasing in exponent value. So y over 3 to the 0 y over 3 to the first, y over 3 squared, and y over 3 cubed. Put in your Pascal's triangle numbers. Do we know what the coefficients will be here? Yes, if you go back to the one we did earlier, I want the 3 to be the second number in my Pascal's triangle. That's going to be this level, so 1, 3, 3, 1. And then finally, I want to clean it up. Okay, so if I clean this up, x over 2 cubed gives you what? X cubed over, the bottom also gets that exponent. So 2 cubed is what?
8.
8. Okay, this goes away because it becomes a 1. Then we're going to be multiplying, so x cubed over 8 is your first term. Then 3 multiplied by x over 2 squared gives you what? X squared over 4 times y over 3, so that's just to the first power. So if you multiply all this together, these 3's will cross-reduce each other. So then you're left with plus x squared y over 4. Okay, so plus x squared y over 4. The part of the cleanup stage is also to be canceling things, reducing things if you can. Then this is going to multiply to give you 3 times x over 2 times y squared over 3 squared gives you a 9. These can cross-reduce, so 3 cancels out, or excuse me, reduces with the 9 to leave a 3. So in your numerator, you just have plus xy squared over 2 times 3 is 6. And then your last part, we're going to have x over 2 to the 0 power, so that reduces to become a 1. And then it's just y cubed over 3 cubed is 27. So plus y cubed over 27. Okay. Any questions on how we did that? No? Okay, 2 more examples and we'll be done. For number 4, this is some very, very, very simple review, okay, that I would like you to not be using your calculators on. Okay, review. If I ask you to do 4C2, 4 combination 2, we're going to go back to the last unit and do some combinations. Okay, how would you set up that combination? 4 factorial over what?
2 factorial.
The 2 factorial and another 2 factorial. So remember, combinations are the total you have to choose from divided by the one on the right and the difference. Okay, remember, NCR, just in case we forget, is equal to n factorial over r factorial multiplied by the difference n minus r factorial. Okay, now if you were to work that out, you'd get 4, 3, 2, and 1 over 2 times 1 and another 2 times 1. These reduce each other away. This reduces to leave you with 2. 2 times 3 equals 6. Okay, and then the last one I want you to work on, I want to know 9C2. Okay, do 9C2 for me. I don't want you to figure it out. I just want you to write it out. So I don't want the actual answer. I just want you to write it out. How would you figure that out? This would be equal to what?
9 factorial over 2 factorial, 7 factorial.
Now, oh, sorry, 7 factorial. All I want you to realize is that that is equivalent to 9 factorial over 7 factorial 2 factorial. How would you write this one in combination form? What is that? 9C7. I would like you to recognize that 9C2 is equivalent to 9C7. Okay? You do need to recognize that those are equivalent. So be able to write an equivalent combination expression. Okay, so 9C2 would be equivalent to 9C7. Just like if I asked you 8C3 is equivalent to 8C what? 5. Okay? So just understand that those are equivalent expressions. Okay? I'm not asking you to solve them. I just want you to be able to write an equivalent expression. And we will be using those equivalent expressions tomorrow in our notes and our homework. Okay? What you guys are going to work on right now is homework is worksheet 2. It is not in your green book. Okay? I'm going to give it to you. And it is going to be numbers 1 through 15. Okay? Worksheet 2, numbers 1 through 15. I will give you the worksheet. Okay? Does anyone have any questions?